Welcome to our very first Zwitterco Evolution webinar featuring our anti-fouling membranes for food, dairy, and biotech processing. I'm Christy Harner, our Vice President of Marketing, and I am thrilled to be hosting today's session. As most of you know, Zwitterco is the global leader in membrane solutions for challenging separations. We help industries treat complex wastewater, purify water for reuse, and maximize efficiency in food processing applications. Our company leverages its breakthrough zwitterionic chemistry to build membranes with unprecedented fouling resistance, overcoming the longest standing limitation with traditional filtration. As you can see from some of our partners listed on the screen, we are already working on many exciting new projects around the world, and we're excited to expand our network to people like you. And I hope you get a lot of insights and ideas from this webinar. All right, so many of you have seen our announcements introducing Expedition, Evolution, and Elevation product lines. So let me just give you a quick intro before we get started. Our Expedition membranes are based on our Zwitter core technology and feature membranes and systems that work together to solve extreme water quality challenges. For more information on our Expedition solutions, be on the lookout for future webinars and announcements or visit our website. Our Elevation membranes are powered by our Zwitter Shield technology with incredible resistance to organic fouling for water and wastewater treatments. They are designed to fit seamlessly into existing membrane processes or new systems built using conventional membrane process design. And today's webinar features our Evolution membranes, which are food-grade process membranes designed for the specific needs of food and dairy processors. These use both Zwitter Shield and Zwitter technologies, depending on the specific product. Okay, speaking of evolution, let's get to our main topic. I'm so excited. Our featured speakers today are John Goodman, the Vice President of Food Processing and Specialties here at Zwitterco. He's got over 35 years of experience in the membrane industry, specializing in process applications. And our Business Development Manager, Scott Brown, with over 30 years of experience in the dairy industry, working at dairy companies, OEMs, chemical suppliers, and membrane manufacturers. Before we begin, please note that at the end of today's presentation, both John and Scott are ready to answer questions that you might have throughout the webinar. So you please use the Q&A icon located at the bottom of your Zoom screen to ask questions anytime, and I'll be choosing the most relevant questions to bring up for discussion at the end. For any questions we don't get to today, our team will actually send you an email with the answer following the webinar. And we're also going to share a lot of the answers for everyone after the webinar, so please check your inbox in a few days for those responses. Okay, last thing before I hand it over to John, I just launched a poll on your screen, and we just want to find a little bit of a detail about our audience members today and who you are, so our conversations and our answers during Q&A can be geared toward the right needs and solutions. So if you could go ahead and start to answer, there are several. If you scroll down, you'll be able to see several on the pop-up there: plant manager, production, R&D, technical services, procurement, and other. Getting a lot of quick answers. Oh gosh, thank you. This is great so far. I'm gonna give it another second because we got a lot of people participating in it. I want to hit 70%. Awesome. Okay, I am going to go ahead and end this poll and then hand this over to John. And let's get started.
Very good. Thank you, Christy, and thanks everyone for joining. I wanted to start by just giving some background. You know, when Scott or myself, anyone from our team, comes and talks with various processors, we always are asking questions. And what we're really trying to understand is, how can our zwitterionic technology help people? How can we help you create more value, lower your total cost of operations? And we get a wide variety of answers. This is I call it a wish list, and it ranges from taking this anti-fouling technology and shortening the cleaning programs, or reducing the chemicals, lowering cost, getting more time, looking for higher operating flux, different performance benefits, and then there's sustainability things like less wastewater to treat, hitting sustainability goals that you all need to meet. And we've kind of taken a look at this whole list, and we summarize it with the bottom line is, people are after increased productivity. the end of the day, we believe that that's what every plant manager is after, is increased productivity. And so we're going to highlight that today. So we get asked, what's new? Now, it's a very, very common question that you ask us is what's new? Because we all know that the membranes being used in industry have been around for decades. And it's very exciting to have something that is truly new and different. And in this case, our technology that we have introduced, because we've been selling it now for quite a number of years, is based on zwitterionic copolymer. And other than, of course, being part of ZwitterCo and learning how to say zwitterionic copolymer very well, what are zwitterions? Zwitterions are small particles that have both positive and negative charges in close proximity. And this makes them extremely hydrophilic or water-loving, which is, of course, very important in any type of an aqueous separation that we're trying to permeate water or an aqueous solution. So the zwitterionic pores in our membrane will attract water, repel organics. And the important thing is it prevents permanent fouling. And that allows for complete recovery with a very moderate cleaning, so to speak. And different industries, different customers can take advantage of that in different ways. Now, on the right side of this slide is an SEM of our first zwitterionic membrane that we made. And as you'll see, it's a thin film composite. And industry is very familiar with thin film composites like RO membranes, where that layer, that active membrane layer for an RO is a polyamide. In the case of our membrane, the active membrane layer is a zwitterionic copolymer, and that's seen in that SEM. A bit of our history in ZwitterCo's been around since 2018. Our first product was commercially introduced in 2021. So we have product that's been in the field now for almost 4 years. That first product was called superfiltration. A very common question we get is, what is superfiltration? Well, superfiltration is what we consider to fall between traditional ultrafiltration and nanofiltration definitions. There's a number of membranes in the industry that fall into this category that are called a number of things: loose NFs, tight UFs, etc. We consider that a superfiltration membrane. Our first product went out in the field in fourth quarter of 2021. The second product that ZwitterCo introduced was a reverse osmosis membrane, brackish water RO, targeted toward industrial water and wastewater. And that was introduced in 2023. So we're going on 2 years of experience there. Then in 2024, things really started accelerating for us. We introduced a second generation superfiltration membrane, which also became our first product that was FDA compliant. And now in 2025, we are introducing a third product family, ultrafiltration, that we call PCM, that we'll be talking about a little later. And we're also extremely excited about our second generation RO, which will be a food grade product. So Scott, please take it away regarding increased productivity.
Absolutely. Thanks, John. So the cool thing about this product is, and all the time that I was a production manager in a whey plant, fairly large whey plant, everybody was on me all the time. Give me more yield, give me back more time. Time and yield is what everyone was wanting as far as corporate was concerned. Give us more product, more uptime, more time for maintenance or PMs, periodic maintenance. That way we can protect against equipment failure. The fact of the matter is, the reason I'm so excited about this product is that it can do that. Just like John said, whenever we go into a plant, the first thing someone asks us is, what's new? And when I actually have something new to tell you, that's when it gets exciting for me. Because what we've seen for the last 30 years that I've been in the industry, it's pretty much been the same thing. There's been small changes or what have you, but this is an actual real change. More output, more uptime, those things. And what's exciting also is shorter, faster cleaning. After spending 4 years with a chemical company, I'm really excited. And the fact of the matter is the chemical company should be in on this as well, because it's exciting that we can shorten your time for cleaning, give you fewer cleaning steps, reduce some actual steps, reduce our water uptake using less flushes, less water to the water filtrate or the wastewater treatment. It's very exciting. Here is an example of the difference in RO cleaning, just in the RO itself, where we remove the enzyme wash. With the removal of an enzyme wash on an RO, it's going to be anywhere from 45 minutes to an hour back to you to use however you want. When we go and look at the UF cleaning, now we can remove one of the alkaline washes as well. One of my customers, one of my friends that's a customer, was on me the other day about chlorides. And he said, if we can remove not only an enzyme, but if we can remove some chlorine, that also removes the opportunity for chlorides to be holed up inside of the element itself that's going to end up in your product. These are things that we're changing. This is what's new. Now, this is the part that gets me excited. This is an actual operating flux from a plant where we have the elements installed today. It's a WPI process. This is an actual field demonstration for more than 2 months. And you can see that that top line is the Zwitter Evolution SF flux, and below is a conventional PES UF flux. Now, mind you, just as John said, the SF is a tighter element, tighter membrane itself. And yet we still have 50 to almost 100% increase in flux. Now, if we can drive your solids higher, and now we don't have to add any more stainless steel, we're not asking you to add any more vessels, no more loops. We're just adding these elements. And we're also shortening your time of downtime. How much difference is that going to make? And the difference in the permeate is zero. John's going to talk about that in a minute. So to me, this is very, very exciting. And I hope it gets you excited as well, that we've actually got field trials that are showing this.
Awesome. Thank you, Scott. I love your excitement for this. I'm going to add another poll because we just want to get engagement from people and hear what you find to be the most important productivity challenges you face. So on your screen, you should see a poll right now that asks what is most important. You can do multi-choice, so you can pick as many as you want, but we're really trying to figure out what are those things that challenge your productivity that you're facing at your plant, at your facility. All right, let's wait for a few more people. Doing that quick response now. I will say, I'll just make a note, excessive membrane fouling is a really high one on the results here. That's probably our top one, and then hours of cleaning and short membrane life, but excessive membrane fouling is definitely on a very high on the list. Okay, thank you guys so much. We're just about 50% of people. Okay, we got, great. Okay, I will pause now. Thank you, and move on to our next slide.
Excellent, thank you, and thanks for the feedback. It's great to be able to get the feedback to that question that I started off with from so many people all at once. This next section, we're going to talk about the 3 evolution membrane types that we're offering, and talk about how they might be used. I'm going to start off with superfiltration, and want to start with that because not only was it the first membrane product that we developed, but Scott just presented the data from toward the back end of a WPI process, and so want to start with that because these membranes are now available today, FDA compliant. We can issue a declaration of compliance for the Evolution SF membranes for whey and milk processing. They are designed to replace conventional tight UF or open NF membranes. And we do have field demonstrations now underway. We're targeting this toward high solids applications. So that data that Scott presented, the retentate coming out of those membranes is in the 28 to 29% total solids range. We definitely see with this membrane that it outperforms at high solids. So that's the top application type that we're after. The second is applications with high fat content. So going back to the poll, excessive fouling, and the whole zwitterionic technology, this membrane actually has no problem with it. It likes environment where there's fat. Very different than conventional membranes. So applications with a high fat content make complete sense for this membrane, or PCM as we'll talk about next. And then the third is one of the applications, for example, targeting is replacing NF in protein concentration. So perhaps in a WPI process, you've got an NF to get to your solids up. This membrane will pass lactose. It will pass sugars. However, where you've got a extremely high concentration of protein and passing a small amount of lactose isn't going to have an impact and be a positive, it can create a lot of value because it can be cleaned far more effectively and with different chemicals than you would with an NF. The next membrane that we've been waiting for quite a while is what we call protein concentration membrane. And this is a UF membrane. And this membrane was designed for the front end of systems. So if SF is in the high solids toward the back end of systems, we needed a product that could go and replace conventional 10K, 20K membranes at the front end of systems. And that's what this membrane is. So PCM, we're very excited. We are now taking orders for field demonstrations or proof of concept testing. But we've got quite a number of orders in already for complete stages for field demonstrations. We are expecting to be able to issue a declaration of compliance for FDA in the next few weeks. So we are targeting this membrane toward various protein concentrations, as you can tell by the name, whether it's dairy, non-dairy, plant, etc. So the next slide shows test data, and I want to thank Tetra Pak for sharing this data with us, and a lot of bars on this chart. And what we're doing is we're looking at both conventional 5 and 10 kilodalton PES membranes with Evolution SF in the darkest bar, and then in the turquoise, the Evolution PCM membrane. In the middle of the chart is data from sweet whey concentration. On the left of that, we've got clean water flux. So we can see what the membranes were doing prior to the test. Then we've got the test itself. And the whey was concentrated about 5.5x to make WPC 35. And then to the right is cleaning. So taking a look in that box at the whey concentration, you can see PCM, though it might have been lower than a 10K on water, once it saw product, it outperformed. And it outperformed all the way from the start at 1x to 5.5x to WPC 35. The other very interesting thing that struck me looking at the chart was how flat the flux curve was for SF. Now again, the data we showed earlier from the back end of the system showed SF outperforming PES membranes at the back end of the system. But at the front end, we knew that it was lower flux. And it was very interesting in this test that by the time we got to WPC 35, even it was outperforming both 10K and 5K PES membranes. Finally, on the right side of the chart shows cleaning. The very first set of bars that says post-flush. Very interesting. If you look at the full recovery of both zwitterionic membranes with just a water flush. It then took multiple cycles and ultimately the addition of chlorine to fully recover the PES membranes from the test. No enzyme was used and no detergent was used in this in that cleaning. So anyway, this was very exciting. The next slide, Christy, will show some of the conclusions from this test. Flux rates higher, as you saw, the flatter flux curve. Very important, no noted difference in permeate. There was no true protein loss. All in a total protein analysis, all the total protein passage was NPN. And then finally, the cleanability was excellent. So that's SF and UF looking at protein concentration applications. And then we get to the third product, reverse osmosis. Now, this product has been in the field already in non-food grade applications, in wastewater or effluent concentration. We have 5 commercial systems that are currently operating in the dairy industry in the US, with the longest one running now for well over a year. And the value that we've been able to demonstrate is removing the enzyme step, as Scott was mentioning earlier. Just removing that enzyme step, we've been able to reduce chemical costs by over 50%. And we've been able to reduce water usage by over 40%. And most importantly, is reducing the cleaning time. The next slide shows the flux data. This goes back to August of last year. It's normalizing the flux for one of the systems that's been in operation for more than a year. This is where we first proved the ability to remove the enzyme step. And as you can see, obviously there's always variations, but the normalized flux has continued to chug along right where it started. So between the chemical cost savings, the water reduction, and the time savings, it's been excellent. And now what we're excited about is the introduction of a food grade product, our next generation product. And Christy will move that forward. And we, along with PCM, we're expecting to be able to issue a declaration of compliance for FDA compliance in the next few weeks. And we are now taking orders for not only field demonstrations, but we've begun taking orders for full systems and full-size installations. And we want to be in a position to supply these by the end of the year. We're targeting this towards skim milk concentration. We're looking at things like permeate concentration, polishers, and other product concentrations that require FDA. So Scott, please, why don't you cover just some of the industries, people we've been talking to, different applications where we believe our technology can be used.
So since June, I've had the opportunity to get out into the field and talk to a lot of you, and very excited about the opportunities in plant protein and blood plasma. That's one of the ones that we've been keying on as well. Sugar processing. We're already doing effluent water reuse, starch derivatives processing, beer dealcoholization. Now it seems wrong, but it's something that we can do. Gelatin concentration, There's just a lot of places where we can use these products. So even in eggs, and John, you've been working with some precision fermentation and enzyme manufacturing. All of this is very exciting. So many places that this element can be used. And we've been using our conventional elements for as long as I can remember in all of these operations. But to be able to give you an element that is going to not take as much chemistry to clean it up, it's going to give you more uptime, that's going to give you the opportunity to work on your equipment a little bit more. From a guy that's worked in a plant that worked 24/7, 365, right? Our biggest concern was, how am I going to fix this when it breaks? And we always just had to do it on the fly. Now we're going to give you a little more time to take care of that. It's very exciting.
Awesome. Thank you. Okay, we're going to move into Q&A now. Unless there's anything more you want to say, John? All right.
No,
Okay, now is the time to go ahead and put in your questions. We've got some time on here. We wanted to leave a lot of time open for just asking John and Scott things. So I'm going to move into our Q&A. I'm going to pull up a few questions that are listed here, and I'm sure you guys will pop up a few more as I go. All right, the first question we want to answer is, how does the surface area per membrane compare to those membranes?
Sure. The thickness of our membrane, our membrane is made on a polyester backing, and so the membrane area in an element is going to be competitive, or the same basically as any other polyester back membrane.
Okay. Let's see. Can you, let's see, what is the MWCO for tight UF and open UF that SF membranes would replace?
So, Scott, you want to? We may
so
both.
The molecular weight cutoff that the SF is going to replace, in my humble opinion, is that we should replace the 5Ks on the back side of your system. And we're also working on some really exciting things on the NF side of it, where we are getting the same retention as you're getting in your NF, but we're getting better flux on protein concentration on an NF at the end of a system. So in WPI, for example, we know we can't use an evaporator to drive the solids up before drying on WPI, because it'll denature the protein. So what we do is we use an NF, right? So we use nanofiltration to remove the water that's remaining, and then we also remove some of the salts or some of the ash to drive up the solids to get it to the point where we can dry it and have a decent bulk density. If we replace that with SF, here are some of the advantages of that. We can drive out a little bit more lactose, so we can drive your protein a little bit higher. We can drive your solids higher. And at the end of the day, when we go to dry your product, if your solids are higher, your bulk density will be higher. So it depends on what you do with your permeate off of that NF. But the fact of the matter is we can use our SF to replace that, and you'll get better cleaning because we can use different chemistry. Where it's UF based, we can use chlorine if need be, or if we want to. And we can also, it'll take less chemistry to clean that than it does your current NF. So to replace your molecular weight cutoff of what you currently have, we would suggest that you replace your 5Ks with the SF and replace your 10Ks or greater with the PCM. We'll have better retention and we'll have better flux on both ends.
Thanks, Scott.
Okay. And I was just going to add, because the question was, what were the molecular weights of the NFs? And we've seen everything from the traditional piperazine membrane that's rated in the 200 to 300 range. There's some NF membranes, loose NF membranes, rated as high as 800, and those are fairly straightforward. The question really is with replacing NF, what else does the NF need to retain other than protein for your product?
Okay. All right, questions are coming in hot now. How is Whitterco membranes different from charged PES that have been around?
Well, I can't say that I'm an expert on the charge PES. Obviously, I'm aware of some of the research that was done. Various PES membranes are an asymmetric membrane with some type of a surface modification. When we talk about PCM or SF, Christie used the term zwittercore. I mean, it's a thin film composite membrane where the zwitterionic layer is the barrier. So it is this is that SEM we showed earlier. It's going to look different because the rejection is being done by that zwitterionic barrier layer.
Okay. All right, a longer question. You ready? Your membranes seem to have great potential. One weak point I see compared to conventional membranes is the limited tolerance toward high temperature and pH, which we in our production rely on for sanitation. How do you ensure with your membrane sanitation in processes that require good hygiene?
I'm going to guess this question is coming from Europe. And I'm going to guess that the person asking the question is using PHT type membranes on polypropylene backing, which are cleaned at high pH and temperature. So without specific, it's going to be difficult to answer this one specifically without getting into the details of the process. We are definitely working on increasing our temperature rating and our temperature capability. Right now, on our data sheet, we rate our membrane at cleaning at 50 degrees C. And that's more for the traditional way of cleaning a polyester back membrane, with or without chlorine, pH range of typically 2 to 11 at 50 C. When we start talking about heat sanitization, there is a possibility to go higher, but we're going to need to talk about that. And frankly, we're going to need to gather data and prove it because it is a new product still, and we don't have experience in the field at some of these temperatures. So that's my guess that we're talking about PHT type cleaning, and we'll be glad to talk to you one-on-one as a follow-up to this.
But as far as sanitization, and I am uncertain, John, and maybe you can clarify for me, in Europe, can they use PAA? I know that they're trying to cut back on chlorine in Europe, but can they use PAA for sanitizing as opposed to heat sanitizing?
My understanding is that some plants can, and some plants can't. There are some plants that are running multiple products that will do just a heat sanitization between products.
Sure.
That way they're not introducing chemicals into their process. And that's why I say it's very customer specific. And that's why this one's tough to give a general answer because of the customer specificity.
Yeah.
I think it'd be fun to try a trial though.
Oh, yes.
Sounds good. And you're right, it was Europe. So good job. What is the typical operating pressure when replacing NF with the new SF? Do you run into pump size issues when changing over?
Scotty, you want to talk that one?
Yep, that's a great question. And I think that we can make it work. Most of the NF that are concentrating, WPI, et cetera, they're running at a lower pressure than standard RO, right? I don't think we're going to run into a problem. Matter of fact, it'll probably become a lot more easy for you to run your pumps. We're going to drive less protein into the surface of the element. I think we're going to see a lot of benefits from this, and I don't think we're going to have any problem with pump sizing.
Awesome. All right. You mentioned FDA compliance, but will you get USDA certified as well?
We are planning on 3A/USDA. We're also pursuing halal and kosher. certification, and then it's going to take a little longer. It'll be into 2026, but we've also begun pursuing EC 1935.
All right, I'll add another compliance question. How is the EU food grade compliance status for RO membranes, and what is the risk of zwitterions migration or leaching? Thanks.
The when it comes to the food grade status, the cost and time goes into the analytical work, and so the data that we're getting back on the analytical that we're using for FDA, and again, there's a lot of different regulatory certifications, and we're starting with FDA. It's a logical first step, and to get that, a lot of data that needs to be created. We have not seen in the data a risk of zwitterions migrating or coming out. As far and I think the question again regarding the new food grade RO, evolution RO.
Yes, the food grade compliance for
EC.
RO.
Yeah, and when we come out as a new technology company, we develop technology platforms. So we talk about a first generation, a second generation, and we develop a zwitterionic platform that we then apply and develop different products with. And so because of the similarity in this current generation of our products, we expect the results for the RO to be the same as that for the SF and PCM. I don't know if did I answer everything?
So
That question.
You can always follow up later needed.
Yeah, and if I didn't, please, we'll follow up, either myself and Leonid in Europe.
Awesome. All right. How was the cost improvement of 50% and 40% less water? Is there a white paper that outlines this?
We do have a written case study that's available on our website from the Evolution RO page. There's a case study on that RO. And Christy, you could probably answer that question better than I can.
Yeah, I can't pull it up, but there is a website page for Evolution RO, and we will have that case study on there. And we'll also check afterwards and send you, the person that asked this, that case study. May just include it with everybody in the follow-up email, because I think that would be helpful. So it's a good question. All right, another question. Have you experienced an application where your membranes were irreversibly failed by organics, not considering blocking of feed channels, i.e. an application where you were not able to clean the membrane sufficiently? And if yes, what type of foulant caused the challenge?
What a great question. I am not aware when it comes to, so I'm going to give a longer answer here. At the beginning of the webinar, Christy talked about ZwitterCore and ZwitterShield technology. And there's more about this on our website. ZwitterCore technology, the SEM I showed you, where the zwitterionic layer is doing the separation, that's ZwitterCore. ZwitterShield is where the zwitterionic layer is acting as a shield. In RO, the RO membrane is rejecting salt. The RO membrane is rejecting sugars, lactose. The zwitterionic layer is rejecting protein. So as far as our membranes with the ZwitterCore technology, SF and PCM, I'm not aware of any application where those membranes have been irreversibly fouled by organics. And again, talking on the wastewater side, early on, we talked about being able to, right now we say we can handle 5% oil. Our membranes like oil and they fully recover. We think that's a huge differentiator. That said, the applications where there has been irreversible fouling have been we have seen that in RO, where the zwitterionic layer is acting as a shield. But there's still an RO membrane that can be fouled. And there are some small organics that have caused issues. But in a lot of those RO applications, there's also issues with inorganics. And our membrane technology addresses organic fouling. It does not address inorganic fouling. So on some of those ROs, it becomes challenging, water, wastewater, to tell exactly what is a cause of that. For the 5 installations we have running on effluent in the dairy industry, those systems are all working very well. And the only issue that we've seen is physical plugging, where pre-filtration wasn't in place.
Awesome. I'm loving this. We have over 60 years of experience in dairy and membranes here on this call. And I've got a couple of questions that are just challenging different things. So here's the next one. Have your membranes been used for water recovery concentration of sugars and soluble side streams in plant protein manufacturing? If so, how do they handle fouling due to leftover insoluble proteins left in the product stream?
We had we did have an installation, or do have an installation at a corn refiner. I wasn't directly involved with that, so I'm going to probably need to follow up with the person who asked the question. We have both SFRO at that site. I don't know that that's necessarily a water recovery application, though. It was really a product concentration, because I remember seeing the feed, and it was a high solids feed, high solids, high viscosity feed. So they're doing really product concentration there. But the question about water recovery and reuse, it's a great one, because I'm really excited about that application. I think it's got huge potential, not just in plant protein, but in anywhere where there's diafiltration water or some type of rinse water or process water that's going to wastewater today. And our membrane technology can recover that water, so we can stop sending it to wastewater, reduce the freshwater demand for the plant. What's been holding us back has been having a food grade product. So that's why we don't have these installations in water reuse for process at this point that we want to have. But we'd be glad to talk to you about that and set up a trial, because again, I think it's going to be a great application for us.
One thing I'd like to interject with that, with the water reclaim, is we're seeing it in a plant that we're working with in Washington State. And one of the comments that I got from the plant was that the permeate quality was so much better than what they were accustomed to. When they, the permeate goes from this polisher that they're using our elements in, and it's going to a tank that goes out then to the river. And they said that over the years, they've had to clean that tank by hand, and then all of the sampling ports and all of that daily to get proper information back to decide when it goes to the river and when it doesn't. And the input that I got back earlier this month when I was at that plant, they were telling me they haven't had to clean it since they installed our elements. Not once. To me, that's exciting for them and exciting for us.
Awesome. Thank you. Okay, we got rapid fire. We got a few more. So let's get to it. What is the life expectancy of the membranes in both RO processes, 6% to 22% solids whey, and UF up to 1.5x CF? You can repeat that if you need.
We don't know yet how long the membranes are going to last. We're targeting at least a 2.5 year life. I mean, when when looking at the economics early on, and looking at pricing, looking at how our different sales models, we're confident the membranes are going to last at least 2.5 years. I think that in a lot of applications they're going to last a lot longer.
Bearing in mind that the only thing that breaks down the surface of a membrane is the cleaning, is the chemistry, right? Product doesn't break down the surface of the membrane. So if we're cleaning less aggressively, we're going to get more life out of it. Mm-hmm. Sorry, John.
No, it's exactly right.
All right, I'm going to hop into a confidence question. What is your confidence for desalination of sweet whey for NF applications?
What is our confidence? The question when it comes to desalination, and I heard sweet whey, but I was assuming salt. This is salt whey.
I got to think it's from a salt belt, right, John? And so there are plants that still use NF, which was what we started with NF in the beginning, right? Is to try to turn salt whey into sweet whey, right? And I think with the SF, I don't think that my confidence would be incredibly high. I would think that the salts would pass right through that SF element.
Oh yeah, the salt rejection of these membranes is extremely low. The biggest issue with salt whey is just the lactose. Is that the lactose is going to pass. So we're going to retain the protein. We're going to pass salt. We're also going to pass lactose.
Yeah.
So that to me is the biggest issue. Is,
yep. And that could create a problem for the permeate stream.
Exactly.
Okay. Let's keep going. We got a few more. They keep coming in, but I'm going to stop us in a few minutes, but these are great questions. All right. Is the RO oxidizer tolerance better or worse than standard RO?
The membrane, there is still a polyamide component to this, and so it is the same. So it's unchanged.
Okay. All right.
So still no chlorine in an RO. I want to reiterate that. No chlorine in an RO.
Thank you, Scott. All right. What is the cost differential of a standard 8-inch RO membrane or an 8-inch UF membrane?
So again, talking about evolution products for food processing, we're not going to get into the specifics in a public forum like this, but I can tell you that the pricing was based on value created, and we've set pricing that's commensurate so that total cost of ownership goes down, so that there is value created. And we've also got different sales approaches, both a direct sale as well as a subscription model that allows less upfront cost that covers paying over time. So we've approached this in a very flexible way, but this is a value-added product.
And nothing would make John and I happier than to come out in the field and talk to you in your plant about how this will work for you.
Yeah, I will say these guys love to go in the field and solve actual problems. All right, I'm gonna ask like 2 more questions. All right. What do you see as the upper limit to the dry matter of RO concentrated skim milk? For example, 30%, 35%, 40%.
Scott, do you have an opinion on this one? I want to hear what you say. I've
got an opinion about everything. I think we can drive the solids higher. I really do, because I think our flux is so much higher. How much higher? You know what? Give me a call, and I'll come out and we'll do a trial and we'll find out. Nothing would make me happier than to come out and do a trial with you, and let's see how high we can drive it. I don't think we have enough experience yet to tell you, but I think we can get there. And from what I've seen to this point, my friends, with that higher flux and the lower pressures on the systems that we wholly install the Zwitterco element in, I have all kinds of confidence that we can drive your solids higher than they're going now.
Amazing. Okay, I know we should have done a raffle to like somebody gets a free trip from Scott to their plant. All right. I got two. Let's do real quick, rapid fire. What would be approximate BOD in RO permeate for sweet whey or milk concentration using this membrane?
I would expect it to be the same as what you're seeing today. In general, in RO, what we're really doing is improving the fouling resistance and the cleanability of the membrane versus the rejection itself.
Okay. Final question. How high pressure can the NF and RO handle?
So it's funny. It's a great question. I think that we've rated the RO at 800 psi, 55 bar, and the SF membrane, I believe we've rated at 600 psi or 40 bar.
Okay.
Our intention, when it comes to pressure, it's really a function of the element construction, and we're building the elements in the same way that conventional membranes are built, because the desire here is drop-in replacement, so you don't have to change your system.
Thank you. And I did get somebody commenting as well that they already have a trial that they're going to be having you come out and do with them. So, if anybody else wants to have have a visit from our team, they're ready to go. All right, we've
Excellent.
got.
Thank you.
Thank you guys. This was an amazing Q&A. I love this. We got one more poll question for those of you who are still on. It should pop up right now. This is really genuinely a simple question for us to learn what you want to hear about next, what you want to learn more about. We're building new content, we're building more materials for evolution, and it's really helpful for us to know from you which things, whether it's a deep dive into tech, economic productivity benefits, product availability information, model details, data sheets, field data and installations. Please let us know in these comments you guys are responding. That's great, because we genuinely want to build materials and give you information that you need. And we want to do a lot more of these next year. John, I'm going to keep this poll up for just a sec, but I'm going to go ahead and move to the summary slide if you want to do your final slide before we head out.
Certainly, thank you. Really, our summary, we categorize the benefits into three categories. We've been talking a lot about different ways there's productivity gains. We see that through the shorter cleaning to free up time, and time equals money. It's the one resource that can't be replaced. So we see productivity from time, this buffer against unplanned downtime, increased production, or freeing up the operators to work on other priorities, the PMs that Scott had mentioned earlier. Lower costs. And it's always very interesting because in talking to people in different industries, most everyone wants lower costs, but we are finding that, at least in food processing, it's the productivity that's even more important than the cost. But anyway, yes, we see definitely benefits in lower costs just by changing the chemical cleaning. And in analysis, depending on your cost for water and wastewater, and this can vary quite a bit. I know there's a lot of water sensitivity in Europe and in different places in North America. There's more cost savings potentially from the water and wastewater than just reducing the chemicals. And then finally, there's a number of sustainability gains. And anytime we start talking about fewer steps to decrease chemical usage, lower the water demand, of course, by eliminating a step, you eliminate the recirculation, the heating, you're also going to reduce energy. So that's the third category of benefits that.
And if I may interject a little bit here too, John, when I started off my visit, I said that corporate was always on me for time and for yield. And now the new buzzword from corporate now is sustainability. And this is something we want to drive towards as well. We want to make your plants have more sustainability, and these things to look better for the whole corporate overlook at the end of the day.
Thank you. All right. Thanks, John. Thank you, Scott. That's all we got for today. Thanks to the many, many people who joined this webinar this morning or this afternoon or wherever you are and asked lots of questions. As I said, we will be collecting all the questions that were asked during the hour, and we'll send up follow-up emails to all of you with answers. Some of them we didn't answer. We'll send you detailed information on that. And then we're going to send everyone a follow-up email with a lot of the questions that were asked with detailed answers. Like we said, the case study data that we have to help make sure that you understand more about the Evolution products, our team, and feel free to reach out to John, to Scott, or to the email on your screen anytime. We would absolutely love to talk to you. John, Scott, thank you so much, and have a great rest of your day. And everybody on here, thanks. Take care.